Now what I'd like to do is show you how to use Gpower to calculate power for a multiple regression design, and also determine the number of participants you would need to achieve a power of 0.80. This example also comes from our SPSS for Intermediate 2 workbook, and it's the first regression, the first simultaneous regression example that we ran. And in this case, our 7 predictor variables were gender, father's education, mother's education, grades in high school, competence, motivation, and pleasure. Our dependent variable was math achievement. When we ran that analysis, our R square was 0.443, and the regression was significant, indicating that the linear combination of those 7 independent variables was explaining or predicting math achievement beyond chance levels. So if we go to Gpower, now again we're using the f-test, because that's what multiple regression does, to test the significance of the regression analysis. And we can go to linear multiple regression fixed model, R square deviation from 0. And this time we're going to calculate the power of that analysis. In this case, SPSS does not give us the power, so we have to rely on a program like Gpower to determine our power or our type 2 error rate. Now again, the effect size is in terms of f squared, which, similar to eta square, f square is equal to the square root of r square divided by 1 minus r square. But again, we don't have to worry about calculating that, because we can determine it in Gpower. And so our squared multiple correlation, or our r square, was 0.443. And so we enter that value in this box, and then we calculate and transfer to the main window. And notice that our f square value is 0.795. We like to have our probability of a type 1 error at 0.05, and in this case we had 68 individuals. Our number of predictors was 7, 1 for each independent variable. And so when we click on calculate, we can see that our power is very good, 0.99. So we had a very adequate sample size in order to be able to achieve a high level of power and reduce the chance of making a type 2 error. Now suppose that we want to combine mother's and father's education into parents' education and drop some of our non-significant independent variables. So let's say we want to determine what number we're going to have, and we want to go back to the effect size table, and we want to look at our values for r square. So let's say that we want to pick up at least a large effect, 0.26. And let's also say that we're going to use 5 predictor variables rather than 7. So in Gpower, we click on Determine, and we want our effect size to be 0.25 at a minimum. And so we're going to calculate and move to the main window. And so our effect size in terms of f² is 0.33. And I need to make this a priori. And I need to do this over again. So that's an important thing to remember. I want my multiple square correlation to be 0.25. And so my effect size is going to be 0.33. And so I've transferred that to the main window. I want my error rate to be 0.05. I want my power to be at least 0.80. And this time I'm going to have 5 predictors instead of 7. So to achieve a power of 0.80 and to pick up a large effect, which in this case is 0.25 in terms of r² and 0.33 in terms of f², I'm going to need at least 45 in my sample. Now, we could also look to see if we wanted to pick up a smaller effect. So let's say I want to pick up at least an effect size of 0.13. So I want at least an r² of 0.13. I can go to Gpower and I can put 0.13 in my squared multiple correlation box, calculate and transfer to the main window. And so now my f² is 0.149, and I'll leave my power at 0.80. I'll leave the number of predictors, I'm going to put that at 5, and then I'm going to calculate. Now you see that I'm going to need more individuals to pick up this smaller effect size. So picking up an effect size that is moderate or smaller than our original effect size that we looked at, 0.25, is going to require twice as many individuals. So kind of a rule of thumb with effect size and numbers of individuals is that the smaller the effect that you want to pick up, the larger the sample size you're going to need. So the more sensitive the effect or the analysis, the larger the effect, the larger the number of individuals will need to be.